Welcome all of you to the chemistry online classes. This is the last class of the coordination compounds. Almost we are in the finishing touch, and in today's class we are going to discuss about the metal carbonyls. Okay, and the metal carbonyls are the class of the organometallic compounds, we can say. Okay, in between metal and carbon there will be a bond formation will going to be takes place. So the metal carbonyls are also said to be organometallic compounds. So actually what are metal carbonyls? Here the carbonyl, that is CO, will going to act as a neutral ligand. When this neutral ligand forms a complex with the metal, when this will going to form a complex with the metal, there is a formation of the metal carbonyl. Okay, so CO is act as a, that is carbonyl acts as a ligand. It can able to form the bond with the metal, and there is a formation of such a type of the complex. So those are nothing but metal carbonyls. Okay, usually in other complexes what happens, the ligand will going to donate the lone pair of electron towards the central metal atom, and in this particularly for the metal carbonyls there is a quite a different bonding will going to be occur, that we will discuss. And this is the first point. The carbonyl is a neutral ligand, forms a complex. Carbonyl is a neutral ligand which can able to form the complex with the metal atom, that is neutral metal atom or central metal atom, to form the metal carbonyl. Okay, and example for the certain metal carbonyls, these are the homoleptic. It means similar type of the those ligands or carbonyls are present here, and the first example here NiCO 4 times, which is a tetrahedral in structure. Okay, that is a tetracarbonyl nickel, and this oxidation state will be 0 itself, like that. Here I have shown 4 examples for the different types of the metal carbonyls, and here FeCO5 times, it is having the trigonal bipyramidal structure, and here CrCO6, it is a octahedral. So all these, in all these cases the carbonyl, that is CO, is making a bond with the metal. That's why these are said to be a metal carbonyls. Okay, so let us discuss about the how exactly the bonding will going to be takes place in case of the metal carbonyls. So look at this is the metal and this is the carbonyl group. Okay, and there is a bonding between the metal and carbon. There is a bonding between the metal and carbon, and this bonding involves both type of the bonds, sigma as well as pi bonds. That's why we can say that metal carbon bond show sigma and pi character, because both bonds are going to be occur here. That's why the metal and carbon will going to show the which type of the character, both character, that is sigma character as well as pi character. Then how the sigma bond will going to be formed? See here, metal to carbon sigma bond formation will going to be takes place. In between metal and carbon there is a sigma bond formation will going to be takes place. The electrons of the carbon, because in the carbonyl it acts as a ligand. Ligand should donate the lone pair of electron towards the central metal atom, and the central metal atom has the empty d orbital, and this empty d orbital is donated with the those are fulfilled by the electrons donated by the carbon of the carbonyl group. So this donation can able to form the sigma bond. So this is the, we can explain metal to carbon sigma bond formation will going to be takes place. How exactly it takes place? It is formed by the donation of the lone pair of the electron of the carbon of the carbonyl group towards the empty d orbital of the metal. Okay, and similarly how the pi bond, here the metal even having the filled d orbitals, the filled d orbitals, these will going to donate for the orbital of the carbon, that is anti-bonding orbital of the carbon, pi star. For this the metal will going to donate, that is back, we can say back bonding will going to be takes place here, that is metal to carbon pi bond formation will going to be takes place. That only I have written here, metal to carbon pi bond, and that is nothing but back bonding. So metal to ligand bonding, this metal to ligand bonding creates a synergic effect. It means both sigma as well as pi bonds are taking place. And then first of all, there is a formation of the sigma bond. How it takes place? The ligand can donate the lone pair of electron to the empty orbital of the metal, and there is a back donation from metal, that is filled orbital, d orbital of the metal can donate towards the carbon. That anti-bonding, that is orbital, pi star orbital is fulfilled the electrons of the metal. So there is a formation of the pi bond, and this creates a synergic effect, and this bonding is called as synergic bonding. And this type of the bonding and this type of the effect strengthens the bond between the CO, that is carbonyl, and metal. So this is how we are going to explain the bonding, that is the structure of bond and how exactly the bonding will going to be takes place in case of the metal carbonyl. So the metal and carbon bond shows two characters, that is sigma character as well as pi character, and metal to carbon sigma bond formation will be there. How it is formed? By the donation of the lone pair of electron from ligand. Which is the ligand? Carbonyl. In that the carbon electrons are donated towards the metal. So there is a formation of the sigma bond, and then there is a back bonding will going to be also takes place. The filled d orbitals of the metal will going to be donated towards the ligand, and it forms the pi bonds. So there is a metal to carbon pi bond formation will also going to be takes place. Such a bonding is known as synergic bonding, and the effect is known as synergic effect. This will going to increase the strength of the bond between carbonyl and metal. So this is how we are going to explain the bonding in case of the metal carbonyls. Okay, and the last bit of the topic, that is regarding the stability of the coordination compounds. So as you know, the coordination compounds are formed by the central metal atom and ligand. When the central metal atom and ligand associate, there is a formation of the complex. So how, see here, this is the central metal atom and this is the ligand. They will associate and they will going to form the complex. Okay, and there is a formation of the stability constant. So as the association, the successive association, it means first I have added ligand to the central metal atom, there is a formation of the Ml complex. And how can I write the stability constant K1? That K1 I can, you know this from your first PUC. Okay, and concentration of the Ml divided by concentration of the M, concentration of the L. Okay, and then this complex is further treated with the one more ligand, that is we are going to get the new complex as Ml2. Here how can I write the stability constant? As K2, as K2 is equals to Ml2 divided by concentration of Ml into concentration of L. So the successive addition of the ligand can able to give the stability. So here K1, K2, K3 are the stepwise stability constant. K1, K2, K3 are the stepwise stability constant. So as the stability constant value increases, that complex entity is said to be a more stable. Okay. And then suppose alternatively the overall stability constant can also be written, alternative method. So how, here I am adding stepwise. Directly if I added 4 ligand to the metal, I am going to get the complex. And here we can write the stability constant B4, and then this is the overall stability constant, and which is equals to concentration of the Ml4 divided by concentration of the metal and the concentration of the ligand. And the overall stability constant and stepwise stability constant are related with each other by this expression, that is B4. B4 is nothing but overall stability constant. Here 4 steps are there, so I have took here as a B4. If there are n number of this step, during that time you can take Bn, that is beta n is equals to K1, K2, K3, K4, so on up to Kn you can able to take. So this is how we can able to explain about the stability of the coordination compounds. I hope so it is understood. And last bit of the topic is the importance of the coordination compounds, that is the application of the coordination compounds. So in the previous class also, while doing introduction, I have said you what is the importance of the coordination compounds, how these coordination complexes will going to be play a role. These can able to play a role in case of the biological system, even it can able to play a role in the medicine field, even it can able to give its contribution towards the extraction of the metal. So many applications are there that you can go for. I am giving you as a homework, you can note down all the application of the coordination compounds. For this topic will going to be finished. If you have any doubts, you can contact me, and then keep watching the video and note down all the points so you can able to understand the concept clearly. Okay, thank you.